Lesson 4.6 covers solving maximization problems using the simplex method. In the two previous lessons, we've looked at all the individual steps to solving a simplex method, all the different parts involved. Setting up the tables, evaluating the tables to get the final solutions, pivoting. These are all steps in the process of solving a system using the simplex method. Well, in this lesson, we're going to look at solving a problem from start to finish. So let's look at the steps involved in doing that. The first step is you're always going to make sure the problem is in standard form. If the problem is not in standard form, you see if you can put it in standard form. This will determine if we can even use the simplex process to solve that problem. Step 2 is if the problem is in standard form or if it can be put in standard form, we're going to then set up the initial simplex table and be sure to include all appropriate labels. Then step 3, we're going to perform pivoting operations over and over until every element in the last row is positive. Sometimes we'll have to do this once, sometimes twice, and sometimes even more than 2 times. Then once all the elements in the last row are positive, we're going to analyze the data and determine the final solution. So just a tip, there are many places along the way to make a careless mistake. So I suggest you go slow and write out all your steps and double check each step. In the first example, I want to maximize p equals x sub 1 plus 5x sub 2. And my constraints are 2x sub 1 plus x sub 2 is less than or equal to 10. X sub 1 plus 2x sub 2 is less than or equal to 10. And x sub 1 and x sub 2 are both greater than or equal to 0. Our first step is to make sure that this problem is in standard form. Well, this problem is in standard form, and if you remember, there are 2 conditions. The first condition is that all variables have to be non-negative. Well, I have an x sub 1 and an x sub 2, and those are both listed as being greater than or equal to 0, so they're not negative. My second condition is that all other constraints are less than or equal to a positive number. Well, my first 2 constraints are both less than or equal to 10, so I do have less than or equal to a positive number. So since both conditions are met, this problem is in standard form. So my step 2 is to set up the initial table. And before I set up my table, I need to make my inequalities become equations by introducing the slack variables. So I take my first constraint, the 2x sub 1 plus the x sub 2, and I'm going to add an s sub 1, and it's going to equal to 10. Then my second constraint, the x sub 1 plus 2x sub 2, I'm going to add an s sub 2, a second slack variable, and it's going to equal 10. Then my third equation comes from my objective function. I have p equals x sub 1 plus 5x sub 2. I move the x's over to the side with the p, and when I do this, they both change signs. So I have p minus x sub 1 minus 5x sub 2 equals 0. So on the quizzes and the test, you're sometimes going to be asked for the equations. These are the equations you need to list exactly like this. Now that I have my equations, I'm ready to set up my initial table. So let's look at what labels we need. It'll always start with our basic variables outside the matrix. Then inside the matrix, I have a p followed by my x's. I just have an x sub 1 and an x sub 2. And then I follow those with my slack variables. Well, I had 2, an s sub 1 and an s sub 2. Then I'm going to have my equal to bar, and I'll list my right-hand side values. So for our initial simplex table, row 1 is 0, 2, 1, 1, 0, 10. Row 2 is 0, 1, 2, 0, 1, 10. And then my row 3 is 1, negative 1, negative 5, 0, 0, 0. Now, it didn't really matter which order you listed the two equations in because those came from the two inequalities. But for simplicity, always list these in the order they're given. That way our answers will match up on the quizzes and the test. And then if you list them in the order they're given, your first slack variable will always be your first basic variable. The second slack variable will always be the second basic variable. And your last basic variable will always be P. So now that I have my initial table, I want to begin pivoting. I find my first pivot element and then complete that pivot operation. So first, to find the pivot element, we're going to first find the pivot column. Well, our pivot column, I look at the negative 1 and the negative 5. The negative 5 is the smallest, so the x sub 2 is going to be my pivot column. Now I find my pivot row by dividing the right-hand side by the x sub 2 values. So 10 divided by 1 is 10. 10 divided by 2 is 5. I take the smallest one that's not negative, which is the 5. So row 2 is my pivot row. Then my pivot element is the number that's in the pivot row and the pivot column, which is a 2. So I'm going to complete the pivot by making the 2 become a 1, and then we're going to make the 1 and the negative 5 become zeros. So let's begin with the 2. To make it become a 1, I'm going to divide row 2 by 2. When I divide row 2 by 2, I get 0, 1/2, the 1 that I wanted, 0, 1/2, and 5. And then recopy rows 1 and 3. Next, I'm going to make the 1 become a 0 and then the negative 5 become a 0. To make the 1 become a 0, I'm going to change its sign and say negative 1. I'm going to multiply that by row 2 because row 2 contains the 1 that's my pivot element. And then I'm going to add that to row 1 because that's the row I want to change. So negative 1 times row 2 is 0, negative 1/2, negative 1, 0, negative 1/2, negative 5. Then add this to row 1, and this gives us our new row 1. So our new row 1, 0 plus 0 is 0. Negative 1/2 plus 2 is 3/2. Negative 1 plus 1 is the 0 that I wanted. 0 plus 1 is 1. Negative 1/2 plus 0 is negative 1/2. And negative 5 plus 10 is 5. So this becomes my new row 1, and I recopy rows 2 and 3. Then next, to make the negative 5 become a 0, I change its sign to a positive 5. I'm going to multiply by row 2 because that contains the 1 that's my pivot element. And then I'm going to add this to row 3 because that's the row I want to change. 5 times row 2 is 0, 5/2, 5, 0, 5/2, 25. When I add this to row 3, it gives me my new row 3. 0 plus 1 is 1. 5/2 plus a negative 1 is 3/2. 5 plus a negative 5 is the 0 that I wanted. 0 plus 0 is 0. 5/2 plus 0 is 5/2. And 25 plus 0 is 25. This is our new row 3, so plug this in for row 3 and recopy rows 1 and 2. Since I've completed the pivot, I've left my basic variables blank. I always reevaluate the basic variables after each pivot is completed. So my last basic variable is always P, and if you look, my column under P remained 0, 0, 1. My next identity column is under X sub 2. The 1 is in row 2, so my second basic variable, or my row 2 basic variable, is an X sub 2. My next identity column is under S sub 1, and the 1 is in row 1, so my row 1 basic variable is S sub 1. Now you look at your table to decide if you need to pivot more or not. So since there's no negative numbers in the last row, we do not have to pivot anymore. This is our final table. So now we're ready to list our final solutions. Well, when I look at that final table, look at your basic variables. X1 was not a basic variable, so X1 is going to be 0. X2 was a basic variable, so go to the right-hand side and there's a 5, so X2 equals 5. And P should always be your last basic variable, so if I go to the right-hand side, I get that P is 25. Now for this example, since this actually came from a linear programming problem, let's go back and look at the original problem and compare our answer. So the original problem said we wanted to maximize P equals X sub 1 plus 5X sub 2. Well, we said that P was 25, so that means that's our maximum, and it occurs when X sub 1 is 0 and X sub 2 is 5. Well, if I plugged the 0 and the 5 into the objective function, I would get 0 plus 5 times 5, which is 0 plus 25, which is just 25. So I did get that P equals 25. Now, if you wanted to double check this and see how it compares to the previous lessons when we were graphing these systems, you could let your X sub 1s just be an X, and you could let all the X sub 2s be Ys, and graph this system, and you would see that if you use the graphing method, you would get the same solution. Now be sure on the quizzes and the tests that you use the method that you're told to use. With the graphing method, I ask for specific information along the way, so you have to use the graphing method to be able to give me that information. The same is true for the simplex method. I'm going to ask you specific parts of the simplex method for each problem. So you have to have worked the problem using the simplex method in order to give me this information on the quiz or the test. On the quizzes or the test, if you end up with the final answer and it's correct, but your information does not match it, you will not get credit for that final answer. So you have to work the problem using the method you're told to use. Well, let's look at the next example. I want to maximize 5X sub 1 plus 4X sub 2. And my constraints are 2X sub 1 plus 3X sub 2 is less than or equal to 8. X sub 1 plus X sub 2 is less than or equal to 2. And then I'm told that X sub 1 and X sub 2 are both greater than or equal to 0. So first I check to see, is the problem in standard form? And this one also is in standard form. Both of my basic variables are greater than or equal to 0. I have X sub 1 and X sub 2 greater than or equal to 0. And both of my constraints are less than or equal to positive numbers. My first constraint is less than or equal to an 8. My second constraint is less than or equal to a 2. So since the problem is in standard form, now I want to set up my initial table. If I look at my constraints, the first two constraints, I need to introduce slack variables to get my equations. So for my first constraint, I'm going to have 2x sub 1 plus 3x sub 2 plus s sub 1, my first slack variable, equals 8. Then for my second constraint, I'm going to have x sub 1 plus x sub 2 plus s sub 2, my second slack variable, and that's going to equal 2. Then my last equation comes from my objective function. I have p equals 5x sub 1 plus 4x sub 2. I move the x's to the side with the p and set this equal to 0. So I have p minus 5x sub 1 minus 4x sub 2 equals 0. So now look at all your variables. So I want to determine which labels I need for my initial table. I'm going to start with my basic variable, and then I'm going to have a column for my p-values. I always follow p with the x's, and I have an x sub 1 and an x sub 2. I follow my x's with s's, and I had an s sub 1 and an s sub 2, and I always end with my right-hand side. So for our initial simplex table, row 1 is 0, 2, 3, 1, 0, 8. Row 2 is 0, 1, 1, 0, 1, 2. Row 3 is 1, negative 5, negative 4, 0, 0, 0. And my initial basic variables are always my slack variables if you keep the equations in the order that they were given. So now we want to pivot until the last row has no negative numbers. As it stands now, my last row does have two negative numbers. I have a negative 5 and a negative 4. My pivot column is the smallest negative value, which is the negative 5. So my pivot column is the x1 column. Now to find the pivot row, I divide the right-hand side by the x1 column values. So 8 divided by 2 is 4, and 2 divided by 1 is 2. I use the smallest non-negative value. So the smallest non-negative value is a 2, so that means my pivot row is row 2. Well, the pivot element is the number that's in the pivot row and the pivot column, so this time it's the 1. So I'm going to complete my pivot operation. The pivot element is already a 1, so I don't need to make it be a 1. That's already done for me. All I need to do now are make the 2 and the negative 5 become zeros. So I make the 2 become a 0 by changing its sign to a negative 2. I'm going to multiply by row 2 because that contains my pivot element. That contains the 1. I'm going to add this to row 1 because that's the row I want to change. And then to make the negative 5 become a 0, I'm going to change its sign to a 5, multiply by row 2 because that contains the 1, and then I'm going to add it to row 3 because that's the row I want to change. So negative 2 times row 2 gives me 0, negative 2, negative 2, 0, negative 2, negative 4. When I add this to row 1, for my new row 1, I get 0 plus 0 is 0, negative 2 plus 2 is the 0 that I wanted, negative 2 plus 3 is 1, 0 plus 1 is 1, negative 2 plus 0 is negative 2, and negative 4 plus 8 is 4. I'm going to go ahead in this example and complete our second 0 before I fill in my table. So let's go ahead and do 5 times row 2 plus row 3. 5 times row 2 is 0, 5, 5, 0, 5, 10. When I add this to row 3, my new row 3, 0 plus 1 is 1, and that 1 should never change. 5 plus a negative 5 is the 0 that I needed. 5 plus a negative 4 is 1. 0 plus 0 is 0. 5 plus 0 is 5. And 10 plus 0 is 10. Now when I recopy my table, rows 1 and 3 will change, but I'm going to keep row 2 the same. So row 1 is 0, 0, 1, 1, negative 2, 4. Row 2 stayed a 0, 1, 1, 0, 1, 2. And my row 3 became a 1, 0, 1, 0, 5, 10. Now, since I completed the pivot, I need to reevaluate my basic variables. So the last basic variable should always be a p, and it is. My second identity column is under x sub 1. The 1 is in row 2, so my row 2 basic variable is an x sub 1. My next identity column is under s sub 1. The 1 is in row 1, so my row 1 basic variable is s sub 1. Now we need to determine if more pivoting is needed. So look at your final row. That final row does not have any negative values, so I do not have to pivot anymore. So since there's no negative numbers in the last row, we don't need to pivot anymore. This is our final table. So since it's our final table, I can list my final solutions. x1 is the row 2 basic variable. So look at the row 2 value under the right-hand side column, or go all the way over to the right-hand side of row 2, and x sub 1 equals 2. X sub 2 was not a basic variable, so it equals 0. And p is always my last basic variable, so go to the right-hand side of the last row, and p equals 10. So I get my solutions are x1 is 2, x sub 2 is 0, and p equals 10. And remember, for your final solutions, you always just want the x's and the p. In our next example, we want to maximize p equals 3x sub 1 plus 2x sub 2 plus x sub 3. And our constraints are 2x sub 1 plus 2x sub 2 plus x sub 3 is less than or equal to 10. Negative x sub 1 minus 2x sub 2 minus 3x sub 3 is greater than or equal to negative 15. And then we have each of our x's greater than or equal to 0. So step 1 is to make sure the problem is in standard form. The way the problem was given to us, it is not in standard form. My second constraint is not less than or equal to a non-negative number. In the second constraint, since I have greater than or equal to a negative number, I am going to be able to put this in standard form. If I take that second constraint, I can reverse the inequality sign and change the sign of the 15 if I multiply each side by negative 1. Multiplying by negative 1 is going to change that greater than or equal to a less than or equal to. And when I multiply by negative 1, I end up with x sub 1 plus 2x sub 2 plus 3x sub 3 is less than or equal to 15. So I'm going to replace that second constraint with this modified constraint. Now my problem is in standard form. So step 2 is to set up the initial table. If I look, I know I'm always going to start with my two constraints. I need to introduce the slack variables. So in the first one, I'm going to add an S1. And in the second constraint, I'm going to add an S sub 2. And these are going to change my inequalities to equal to's. So I end up with 2x sub 1 plus 2x sub 2 plus x sub 3 plus s sub 1 is equal to 10. And then the second one, x sub 1 plus 2x sub 2 plus 3x sub 3 plus s sub 2 equals 15. Then I get my third equation from the objective function. Move each of the x's over to the side with the p, and this changes the sign of each one. So I end up with p minus 3x sub 1 minus 2x sub 2 minus x sub 3 equals 0. So if I look back at my equations, I'm going to begin with the column for my basic variables, which is outside the matrix. Then I have a P, and then I have 3 X's, followed by my 2 slack variables, and then I end with the right-hand side. So take the numbers from the equations and enter them into your table. And when you do this, in row 1, I get 0, 2, 2, 1, 1, 0, and then that equals 10. In row 2, I get 0, 1, 2, 3, 0, 1, and that equals 15. And then in row 3, I have 1, -3, -2, -1, 0, 0, and that equals 0. In my initial table, the basic variables are always my 2 slack variables and then the P. Now that we have our initial variables, we need to pivot until the last row has no negative numbers. So first we find our pivot column. We find the smallest negative number in the last row. The smallest negative number in the last row is the -3. That's in the x1 column, so my pivot column is x sub 1. To find the pivot row, I take the right-hand side and I divide the numbers by the elements in the pivot column. So 10 divided by 2 is 5. 15 divided by 1 is 15. I use the smallest non-negative quotient, which is the 5. So row 1 is my pivot row. Then my pivot element is the number that's in the pivot row and the pivot column, and that's the 2. So since our pivot element is a 2, we make that number become a 1. And we make the other numbers in that column, the 1 and the -3, become zeros. So I'm going to use my row operations and first make the 2 become a 1. To make the 2 become a 1, I'm going to divide row 1 by 2. This is going to change row 1, and rows 2 and 3 are going to be the same. So if I divide row 1 by 2, I get 0, 1, 1, 1/2, 1/2, 0, and 5. And then rows 2 and 3 stay the same. Now I need to make the 1 and the -3 become zeros. To make the 1 become a 0, I'm going to change its sign to a -1. I multiply by row 1 because it has the 1 that was my pivot element. And I add that to row 2 because that's the row I want to change. To make the -3 become a 0, I change its sign to a 3. I multiply by row 1 because that's the 1 that was my pivot element. And then I add it to row 3 because that's the row I want to change. So I begin -1 times row 1 gives me 0, -1, -1, -1/2, -1/2, 0, and -5. Then I add this to row 2, and this gives me my new row 2. 0 plus 0 is 0. -1 plus 1 is the 0 that I wanted. -1 plus 2 is 1. -1/2 plus 3 is 5/2. -1/2 plus 0 is -1/2. 0 plus 1 is 1. And -5 plus 15 is 10. Now I'm going to go ahead and multiply 3 times row 1 and then add row 3. So 3 times row 1 gives me 0, 3, 3, 3/2, 3/2, 0, 15. And then if I add row 3, this will give me my new row 3. So 0 plus 1 is 1. 3 plus a -3 is the 0 I wanted. 3 minus 2 is 1. 3 halves minus 1 is 1 half. 3 halves plus 0 is 3 halves. 0 plus 0 is 0. And 15 plus 0 is 15. So I'm going to keep row 1 the same, and I'm going to change rows 2 and 3. So when we do this, I have the matrix 0, 1, 1, 1 half, 1 half, 0, 5. And then row 2 is 0, 0, 1, 5 halves, negative 1 half, 1, 10. And then my last row is 1, 0, 1, 1 half, 3 halves, 0, 15. Since I pivoted, I need to change my basic variables. My last basic variable is always p. So now look at the column under x sub 1. That is the identity column. I have a single 1 and zeros everywhere else. Since the 1 is in row 1, my row 1 basic variable will be x sub 1. Then look for another identity column, and that's under s sub 2. So s sub 2 is going to be a basic variable. Since the 1 is in row 2, s sub 2 is going to be row 2's basic variable. Now look at your final row. It contains no negative elements, so this is my final table. Since this is my final table, I can determine my final solutions. The x sub 1 is a basic variable, so it's row 1's basic variable. So look at the right-hand side for row 1, and there's a 5. So that tells me that x sub 1 equals 5. X sub 2 and x sub 3 were not basic variables, so they both equal 0. And p is always your last row, and its right-hand side is 15, so p equals 15. Now let's look at the next problem. I want to maximize p equals 5x sub 1 plus 10x sub 2. And my constraints are 4x sub 1 plus 12x sub 2 is less than or equal to 180. 8x sub 1 plus 8x sub 2 is less than or equal to 160. And then I have x sub 1 and x sub 2 are both greater than or equal to 0. So my step 1 is to check and make sure this is in standard form. This problem is in standard form. I have both of my variables are greater than or equal to 0. That's the first thing you check for. The second thing you check for is make sure the other constraints are less than or equal to a non-negative number. And they are. I have less than or equal to 180 and less than or equal to 160. So step 2, I need to set up my initial table. The initial table always uses equations, so I need to take my constraints and my objective function and turn them into equations in the form that I need. So for my two constraints, I'm going to add the slack variables, S1 to the first constraint and S2 to the second one. So when I add my slack variables, I end up with 4x sub 1 plus 12x sub 2 plus s sub 1 equals 180, and 8x sub 1 plus 8x sub 2 plus s sub 2 equals 160. Then for my objective function, move the x's to the side with the p, and when you do, they change signs. So I end up with p minus 5x sub 1 plus 10x sub 2, and this should always equal 0. So now I need the following labels. You always begin with the basic variables listed outside the matrix. Then inside the matrix you've got p followed by your x's. This time I just had an x sub 1 and an x sub 2. You follow the x's with the s's, and I had two slack variables. And then you end with the right-hand side. So take the numbers from the three equations and put them in the initial simplex table. Your basic variables always begin with the slack variables, S1 and S2, and then the last basic variable is always P. So for row 1, I have 0, 4, 12, 1, 0, and that equals 180. Row 2, I have 0, 8, 8, 0, 1, and that equals 160. And then for my final row, I have 1, -5, -10, 0, 0, and that equals 0. So now we're going to pivot until the last row has no negative numbers. So we begin by finding our pivot column. Look for in the last row for the smallest negative value, and this is -10. That's in my x2 column, so my pivot column is x sub 2. Now I take the right-hand side and I divide that by the elements from the x sub 2 column to get my pivot row. So 180 divided by 12 is 15. 160 divided by 8 is 20. I use the smallest non-negative value, which is 15. So my pivot row is row 1. For the pivot element, take the number that's in row 1 and the x sub 2 column, the pivot row and the pivot column, and that's the 12. So since our pivot element is the 12, we're going to make the 12 become a 1, and all the other elements become a 0. So the 8 and the -10 need to become zeros. So we're going to begin by making the 12 become a 1. To do this, I'm going to divide everything in row 1 by 12. And we'll keep rows 2 and 3 the same. So if I divide row 1 by 12, be sure to use fractions and keep those as reduced fractions. I get 0, 1/3, the 1 that I wanted, 1/12, 0, and 15. And then recopy rows 2 and 3. Now I need to make the 8 and the -10 become zeros. To make the 8 a 0, I change its sign to a -8. I multiply by row 1 because that has the 1 that's my pivot element. And I add it to row 2 because that's the row I want to change. Then to make the -10 become a 0, I change its sign to a +10. I multiply by row 1 because that has the 1 that's the pivot element. And I add it to row 3 because that's the row I want to change. So -8 times row 1 gives me 0, -8/3, -8, -2/3, 0, and 15. And I do encourage you to use your calculator for these, especially with the fractions. When I add row 2, I'm going to end up getting my new row 2. 0 plus 0 is 0. -8/3 plus 8 is 16/3. -8 plus 8 is the 0 that I wanted. -2/3 plus 0 is -2/3. 0 plus 1 is 1. And -120 plus 160 is 40. Now 10 times row 1 gives me 0, 10/3, 10, 5/6, 0, and 150. When I add row 3, this is going to give me my new row 3. So 0 plus 1 is 1. 10/3 minus 5 is -5/3. 10 minus 10 is 0. 5/6 plus 0 is 5/6. 0 plus 0 is 0. And 150 plus 0 is 150. So I'm going to keep row 1 the same and change rows 2 and 3. So row 1 stayed 0, 1/3, 1, 1/12, 0, 15. The new row 2 was 0, 16/3, 0, negative 2/3, 1, and 40. The new row 3 was 1, negative 5/3, 0, 5/6, 0, and 150. Now that I've completed my pivot, I need to label my basic variables. The last basic variable is always a p. Then if I look in my x sub 2 column, I have the 1 and the zeros. Since the 1 is in row 1, row 1's basic variable is x sub 2. If you look under s sub 2, I have the 1 and the zeros. This time, since the 1 is in row 2's basic variable is s sub 2. Now check your last row. So since there is a negative number in the last row, we've got to pivot again. You don't ever stop if there's a negative number in the last row. You keep pivoting until the last row is all non-negative values. So I need to pivot again, so I've got to find my pivot element. I begin with the pivot column. The only negative value that I have is the negative 5/3, and that's in the x sub 1 column. So my pivot column is x sub 1. For my pivot row, I divide the right-hand side by the elements in the x sub 1 column. So 15 divided by 1/3 is 45, and 40 divided by 16/3 is 15/2. 15/2 would be 7.5 or 7.5 if you made it a decimal. I take the smallest non-negative value, and this time it would be the 15/2. So row 2 is my pivot row. Well, the pivot element is the 16/3 because that's in the pivot row and the pivot column. So I need to make that 16/3 become a 1, and then I need to make the other elements, the 1/3 and the negative 5/3, become zeros. To make the 16/3 become a 1, I'm going to divide row 2 by 16/3. And I suggest you use the fraction button on your calculator. So this is going to change row 2, and rows 1 and 3 will remain the same. So row 2 now becomes 0, 1, 0, negative 1/8, 3/16, and 15/2. And then recopy rows 1 and 3. Now I need to make the 1/3 in row 1 become a 0 and the negative 5/3 in row 3 become a 0. To make the 1/3 become a 0, I change its sign to a negative 1/3. I multiply that by row 2 because that has the 1 that's my pivot element. And I'm going to add that to row 1 because that's the row I want to change. To make the negative 5/3 become a 0, I'm going to change its sign to positive 5/3, multiply by row 2 because row 2 has the 1 that's the pivot element, and add that to row 3 because that's the row I want to change. So let's begin with the 1/3. Negative 1/3 times row 2 is 0, negative 1/3, 0, 1/24, negative 1/16, and negative 5/2. When I add this to row 1, my new row 1, 0 plus 0 is 0. Negative 1/3 plus 1/3 gives me the 0 that I wanted. 0 plus 1 is 1. 1/24 plus 1/12 is 1/8. Negative 1/16 plus 0 is negative 1/16. And negative 5/2 plus 15 is 25/2. Now 5/3 times row 2 gives me 0, 5/3, 0, negative 5 over 24, 5 over 16, and 25 over 2. When I add row 3, this gives me my new row 3. 0 plus 1 is 1. 5/3 minus 5/3 gives me the 0 I wanted. 0 plus 0 is 0. Negative 5 over 24 plus 5/6 gives me 5/8. 5/16 plus 0 is 5/16. And 25 halves plus 150 is 325 halves. So I'm going to keep row 2 the same, and I'm going to replace rows 1 and 3 with our new row 1 and our new row 3. So my new row 1 was 0, 0, 1, 1/8, negative 1/16, and 25 halves. Row 2 stayed the 0, 1, 0, negative 1/8, 3/16, and 15 halves. And my new row 3 was 1, 0, 0, 5/8, 5/16, and 325 halves. Now that I've completed the pivot, I need to label my basic variables. My last basic variable was P, and it did not change. If I look under the X1 column, I've got an identity column. I've got the 1 and the zeros. Since the 1 was in row 2, row 2's basic variable is X sub 1. Then look under your X sub 2 column. I've got another identity column. I've got the 1 and the 2 zeros. This time the 1 was in row 1, so row 1's basic variable is X sub 2. Now look at your final row. I don't have any negative values, so this means this is my final table. I don't have to pivot again. Since this is my final table, I look at my basic variables. I have both values for the x's and the p. X sub 1, go to the right-hand side of row 2, was 15 halves. X sub 2 is in row 1, so go to the right-hand side for row 1, and you get X sub 2 equals 25 halves. And P is always your last row, so P equals 325 halves. Well, now let's look at the final example. And with this example, it's pretty much as hard as it gets. I've given you a large system, 3 rows and 3 x variables. It's got lots of fractions and it ends up having no solution. In this example, I want to maximize P equals 2x sub 1 plus 4x sub 2 plus x sub 3. And my constraints are negative x sub 1 plus 2x sub 2 plus 3x sub 3 is less than or equal to 6. Negative x sub 1 plus 4x sub 2 plus 5x sub 3 is less than or equal to 5. Negative x sub 1 plus 5x sub 2 plus 7x sub 3 is less than or equal to 7. And then I have each of my x variables greater than or equal to 0. So first we always check, and this problem is in standard form. Each of the x variables that I was given have been set greater than or equal to 0. Then look at your other constraints. They're all less than or equal to a positive number. So if these two conditions are met, the problem is in standard form. So now I want to set up the initial table. So this time I'm going to have 4 rows or 4 equations. I have 3 inequalities for my constraints. So I'm going to have to introduce 3 slack variables. For the first inequality, I add the s sub 1, and I get negative x sub 1 plus 2x sub 2 plus 3x sub 3 plus s sub 1 equals 6. In the second inequality, I add the s sub 2, and I get negative x sub 1 plus 4x sub 2 plus 5x sub 3 plus s sub 2 equals 5. And then my final constraint, I have negative x sub 1 plus 5x sub 2 plus 7x sub 3 plus an s sub 3, and that equals 7. Then I'd go to my objective function and I move the x's to the side with the p and set it equal to 0. So I have p minus 2x sub 1 minus 4x sub 2 minus x sub 3 equals 0. Now that I have my 4 equations, I'm ready to set up my initial table. So this time I'm going to start with my basic variable, and then I'm going to have a column for p. I have 3 x's, followed by my 3 slack variables, my 3 s's, and then my right-hand side. So my initial simplex table, the basic variables are my 3 s's and then my p. Row 1 is 0, -1, 2, 3, 1, 0, 0, and that equals 6. Row 2 is 0, -1, 4, 5, 0, 1, 0, and that equals 5. Row 3 is 0, -1, 5, 7, 0, 0, 1, and that equals 7. And then my fourth and final row is 1, -2, -4, -1, 0, 0, 0, because it didn't have any slack variables, and that always equals 0. Now I need to pivot until the last row contains no negative numbers. So I begin by finding my first pivot element. So find your pivot column, look at the last row, and find the smallest negative number. My pivot column this time is x sub 2 because -4 was the smallest negative number. Now to find my pivot row, I divide the right-hand side by the pivot column values. So 6 divided by 2 is 3. 5 divided by 4 is 5/4, or if you want to go ahead and make that a decimal to make it easier to compare to the other values, it's 1.25. And 7 divided by 5 is 7/5, or as a decimal, it's 1.4. So the smallest value is in row 2. So row 2 is my pivot row. The pivot element is the 4 that's in row 2 and the x sub 2 column. It's in the pivot row and the pivot column. So I'm going to make that 4 become a 1 and make all the other values, the 2, the 5, and the -4, become zeros. Now I use decimals just to make it easier to compare those ratios. But when you're completing the work, never use decimals in your simplex tables. Always use fractions. If you use decimals on the quizzes and the test, you will not get credit for those problems. So I begin by making the 4 become a 1. So I'm going to divide row 2 by a 4. When I do this, I keep rows 1, 3, and 4 the same. Row 2 becomes 0, -1/4, and then the 1 that I wanted, 5/4, 0, 1/4, 0, and 5/4. And as I mentioned, you just recopy rows 1, 3, and 4. Now that I have my 1, I need to make the 2, the 5, and the -4 become zeros. To make the 2 become a 0, I'm going to change its sign to a -2. I'm going to multiply by row 2 because that's the row that has the 1 that's the pivot element. And then I'm going to add that to row 1 because that's the row I want to change. Then to make the 5 become a 0, I'm going to change its sign to a -5. I'm going to multiply by row 2 because that has the 1, that's my pivot element. And I'm going to add that to row 3 because that's the row I want to change. And then finally, to make the -4 become a 0, I'm going to change its sign to a 4. I'm going to multiply by row 2 and then add that to row 4. So -2 times row 2 gives me 0, 1/2, -2, -5/2, 0, -1/2, 0, and -5/2. If I add this to row 1, this gives me my new row 1. So for my new row 1, I have 0, -1/2, 0, 1/2, 1, -1/2, 0, and 7/2. Next, I have -5 times row 2, which gives me 0, 5/4, -5, -25/4, 0, -5/4, 0, and -25/4. When I add row 3, this gives me my new row 3, which is 0, 1/4, 0, 3/4, 0, -5/4, 1, and 3/4. And then finally, 4 times row 2 gives me 0, -1, 4, 5, 0, 1, 0, 5. If I add row 4, this gives me my new row 4, which is 1, -3, 0, 4, 0, 1, 0, 5. So I'm going to keep row 2 the same and rewrite my new rows 1, 3, and 4. So when I do this, my new row 1 was 0, -1/2, 0, 1/2, 1, -1/2, 0, and 7/2. My row 2 stayed the same, 0, -1/4, 1, 5/4, 0, 1/4, 0, and 5/4. My new row 3 was 0, 1/4, 0, 3/4, 0, -5/4, 1, and 3/4. And then my new row 4 was 1, -3, 0, 4, 0, 1, 0, 5. Since I completed a pivot, I need to relabel my basic variables. The P column contains the identity column, the zeros and the 1, and the 1 is in the last row, so P is my last basic variable. That should always happen and never change. My next identity column is under X sub 2. The 1 is in row 2, so the row 2 basic variable is X sub 2. My next identity column is under S sub 1, and the 1 is in row 1, so my S sub 1 is row 1's basic variable. And then my final identity column is under S sub 3. The 1 is in row 3, so S sub 3 is my last basic variable. Well, if you look at your last row, I have a negative number. So since there's a negative number in the last row, we've got to pivot again. So for my second pivot element, begin by looking for the pivot column. The smallest negative number is that -3. That's my only negative value in the last row. That's under X sub 1, so my pivot column is X sub 1. So now I take my right-hand side and I divide it by the x sub 1 values. Well, if I divide 7/2 and 5/4 by the x sub 1 values, I'm going to get negative quotients because the right-hand side is positive and those x values are negative. So the only positive quotient that I'm going to have is in row 3. So I know my pivot row is going to be row 3. So the pivot element is the 1/4 that's in the pivot column and the pivot row. So I'm going to make that 1/4 become a 1. And then I'm going to make the -1/2, the -1/4, and the -3 all become zeros. So we're going to begin by making the 1/4 become a 1. I do this by dividing row 3 by 1/4. Now you can take your calculator and use your fraction buttons and divide by 1/4. A shortcut, dividing by 1/4 is the same as multiplying by 4. So you multiply all the row 3 elements by 4. So either way you do this, for row 3 you get a 0, the 1 that we wanted, a 0, a 3, a 0, a -5, a 4, and a 3. Rows 1, 2, and 4 stay the same. So now I need to make the -1/2, the -1/4, and the -3 become zeros. For the -1/2, I change its sign to 1/2. I multiply by row 3 because that contains my 1, that's my pivot element. And I add that to row 1 because that's the row I want to change. To change the -1/4, I multiply row 3 by 1/4 and add row 2. To change the -3, I multiply row 3 by +3 and add that to row 4. For practice, I suggest you do these on your own. Just pause the video, work these problems on your own, and then play the video to check your answers. When I multiplied 1/2 times row 3 and added row 1, I got 0, 0, 0, 2, 1, -3, 2, 5. When I multiplied row 3 by 1/4 and added row 2, I ended up getting 0, 0, 1, 2, 0, -1, 1, and 2. When I multiplied row 3 by 3 and added row 4, I ended up getting 1, 0, 0, 13, 0, -14, 12, and 14. So after you've checked your 3 new rows, add those to your matrix, and you're going to keep row 3 the same. So row 1 was 0, 0, 0, 2, 1, -3, 2, 5. Row 2 was 0, 0, 1, 2, 0, -1, 1, 2. Row 3 was 0, 1, 0, 3, 0, -5, 4, 3. And then row 4 was 1, 0, 0, 13, 0, -14, 12, and 14. Since I completed a pivot, I need to reevaluate my basic variables. The last basic variable should always be P, and that's because your P column should never change. You have 3 zeros, and then the 1 is in row 4, so my row 4 basic variable is a P. My next identity column is under x sub 1. The 1 is in row 3, so row 3's basic variable is x sub 1. My next identity column is under x sub 2. The 1 is in row 2, so row 2's basic variable is x sub 2. And the last identity column is under S sub 1. The 1 is in row 1, so row 1's basic variable is S sub 1. Now look at your last row. It still has a negative number, so I have to pivot again. You always keep pivoting until you have no negative values in that last row. So I begin with my pivot column. The only negative value in row 4 in the last row is the negative 14. That's in the S sub 2 column, so my pivot column is S sub 2. Now I take my right-hand side and I divide it by the S sub 2 values to get my pivot row. When I do this, 5 divided by negative 3 is negative, so I cannot use it. 2 divided by negative 1 is negative, so I can't use it. And 3 divided by negative 5 is negative, so I can't use it. So I don't have any quotients that are not negative. So because I don't have a non-negative quotient, I can't complete this pivot. Since I can't complete this pivot, the problem is unbounded and it has no maximum. So when you're given the final solution, you say the problem has no solution, or just simply write no solution.